The aim of this experiment is to crack liquid paraffin. Liquid paraffin contains long chain hydrocarbon molecules that are broken into smaller ones by the action of heat. The apparatus that we're going to use today is a boiling tube with a delivery tube that's going to collect the gas that's produced over water. The first thing I need to do is to place some ceramic wool into the bottom of the tube and then soak that with liquid paraffin. In goes the ceramic wool, followed by some liquid paraffin. It's important when you're adding the liquid paraffin to try not to get it down to the sides of the tube. We need to add quite a bit in order to ensure a fair amount of product. Next, I clamp the tube in position. It's approximately horizontally, and I need to clamp it at the end near the bung because I'll be heating here and here during the experiment. Next, the surface on which the hydrocarbon molecules will be cracked, and this is a ceramic catalyst. We're using broken pot, and that's placed in the center of the tube. This models the type of cracking procedure carried out at the oil refinery, where a ceramic catalyst is used to break down the molecules in the heavy oil fractions and produce more useful, shorter chain hydrocarbon molecules. One more spatula measure should do it. Last thing to do is to put the delivery tube in position and make sure that everything is airtight. It needs to be firm, but not over firm. That looks about right. Safety aspects. The main safety aspect during this experiment is that the gas will be collected over water from the Bunsen valve there, and as the experiment goes on, it's important not to allow suckback of the water, or the water turns into steam and we can get an explosion here. In a moment, I'll start heating. The first effect of the heat will be to heat the air inside the tube. This will expand and produce numerous bubbles there, but they are not product gas molecules. We have to wait some time before the product's produced. First, I'll be heating the ceramic pot here to get that nice and hot, and then when that is nice and hot, I'll move the Bunsen down along the tube to the liquid paraffin, encouraging that to turn into a vapor, and then the vapor will travel along the tube, come in contact with the hot pot, and that's where the cracking will occur. The long chain gas molecules will produce smaller gas molecules, which will then be produced underwater over here, and we'll collect them in little test tubes. Now we start heating. I need to use a hot flame and start by heating the catalyst. Notice the air bubbles coming out there. And the air bubbles are getting much slower. There was in fact a little bit of liquid paraffin that had drifted down. And may in fact be causing some kind of product to be formed. Right, the pot's in fact turning black on the outside due to some interaction with the organic material, and I'll now start to heat up the liquid paraffin, and we might start collecting some of the product. This is quite usual for the gas bubbles to be produced slowly at first, but as the cracking process gets underway, the stream of bubbles becomes quite fast and reliable. see that the apparatus is now very hot indeed, and we've got some smoky residue being collected here at the end of the tube before exiting through the delivery tube. And that's one tube collected. We'll carry on to see if we can collect 2 or 3 tubes of gas, which we will then be able to test using a variety of procedures. And gas production really is quite rapid now. It's important for me to keep heating because if I stop, then the reaction tube starts to cool and I'll get the gases inside cooling down and water may enter the apparatus through the Bunsen valve. Three tubes collected, 1 more to go. And there we have it, that's the product material. Now the easiest way for me to remove the delivery tube from the water bath is to take away the heat and simultaneously pick up the apparatus like so. There's a small chance of the water going back up the tube, so it's important to keep an eye on it as it cools. In fact, I'll move it over here. Here's the product that we obtained from the cracking of liquid paraffin. It's a gaseous product. We've got 4 tubes and we can carry out 4 tests. The first test I'm going to carry out is a flammability or combustion test to see if the gas in fact burns. This is achieved with a lighted splint. Light the splint in the Bunsen flame. And now I will remove the cork. Remember, it's quite damp at the top. The gas was collected underwater. And see if we can see any evidence of a flame. I don't know how well you can see that in the camera. Nothing really lighting there. So the first tube, the first test, not entirely convincing. Perhaps we'll have better luck further along. The second test I'll carry out is the addition of bromine water and shake that with a sample of the gas. And we can tell if the bromine water loses its colour that the product is quite different in identity from the reactant hydrocarbon. Again, take a small sample of the liquid, which has a yellow coloration, introduce it into the tube, replace the stopper and shake. Head down. And what we're looking for is a loss in the coloration. And that was quite fast indeed. The yellow colour, if you can see it, has completely disappeared, and the product gas from the cracking experiment has decolorized bromine water. A similar test is to look for decolorization of dilute acidified potassium manganate 7. This is purple in color, and again we'll look for a loss of color if certain unsaturated molecules are present. 2 solutions to add this time. First, a small amount of nitric acid, a few drops, followed by some dilute potassium manganate 7. I've got quite a lot in there. should be able to see an intense dark purple colour, or at least a dark tube. If I shake it up, we may get a result. You can see the colour's changed. In fact, it's gone dark brown. It's not entirely discolorized, but it's changed colour. That's due to the production, I believe, of manganese dioxide. And in fact, I can see that as a pale solid precipitate. If we let that settle, the solution above should indeed prove colourless. The fourth test that you can do is to sample the odour of the product. Small chain hydrocarbons smell very petrol-like, whereas the liquid paraffin, to begin with, has no odour at all. This is, of course, a test that you cannot capture on film, but I'll do it nevertheless. And yes, that's quite a different smell. Having just sampled that for its odour, I will see if I can light the gas again. Remember, combustion requires a fuel, which is my gaseous product here, and oxygen. So if I remove the stopper, the gas may slowly mix with the oxygen, and I'm looking for a flame at the top of the tube. And there, well, there was quite a flame to begin with. That concludes the tests for the products of cracking liquid paraffin. You should be able to identify the nature of the product gases from the cracking process by the results of those tests.